Hello, friends! Today is a beautiful day to talk about Scala and, in particular, Scala 3. So, last time, me and my friend Anton had a chat about Scala 3 new features, such as union types, new syntax, enums, opaque types, and all this great stuff. But there was one, not even a feature, but rather a part of Scala that was significantly reworked in Scala 3, and this is implicits. So today we are going to talk about implicits, their use cases, how implicits are different in Scala 3, in which sense the new system is better and maybe worse. So let's check this out. Awesome. So today we have my good friend Anton, who is a staff engineer at Disney Streaming Services. And he will tell us a little bit more about implicits in Scala 3. Let me bring him in. Hello, Anton. How's it going?
Hey, Artem. That's good. Good to be here.
You don't sound too excited.
Do you want to do it again? Oh, so happy to be here. Yes, implicit.
Awesome. That's much better. All right. So before we dive into coding and all this stuff, there was one glaring omission in the last video. When I introduced you and asked about your Scala experience, what I forgot to ask was, what do you use at work? What are the libraries? What are the, the structure of your application? Do you use Zio, type level stack, Douglas Final, some custom stuff? Maybe you have cake patterns somewhere there. So would you mind sharing a little bit about this?
So the answer to all of the things that you listed is yes.
We
use that, we use everything. So basically think of a functional pattern and we're going to use it at some point or the other. Because you got to remember that code base is multiple evolutions flattened into one. But there is kind of convergence inside where the pure functional stack, be it Zio or type level stack, is what we converge towards. And a lot of our stuff is already running it and we quite enjoy it. But obviously there's a lot more learning to be done in which places things like Zio shine with its explicit error channel and its sort of dependency injection codified in the monad itself, or where it's easier to just go with type level stack and this abstract taglessy finally pattern, basically. So, but we have mixtures of both. Usually not within the same team. I think like when the team is choosing the technology that fits their needs and the particular way they want to write code, I think it's unlikely to have things that are somewhat opposite of each other, things like Zio and things like type level stack. So
sure.
I personally work mostly with the type level stack.
Right. So is it your favorite, or it just happened to be so?
It was the thing that I was introduced to, and it was really strange that I was introduced to PureFP not through using the IO monads directly, which would be a natural choice because it just makes things so much easier to learn. I was actually introduced to it directly from that kind of type class pattern, where you codify the least common, the least powerful boundary that your function needs to work. So I was introduced to that first, which made the learning curve quite horrific because not understanding how all those things fit together. I have been looking at Zio. There is a lot of interesting stuff in it, but so far I didn't find myself being so attracted to what Zio sells as to switch. But I do think that some of the tooling and some of the stuff that is available in Zio is actually very cool. And I'm actually glad to see competition between different IO monads in the Scala space reigniting again, because at the end of the day, it's going to be better for everyone if there is no status quo that just kind of lives on and rots.
Sure.
So I think it's going to be interesting.
I mean, let's just hope that the competition is not in the number of parameters, type parameters on your monad.
I mean, there's Zio 2.0. coming out this year, and I think 2.0 means there's going to be double the number of type parameters. And I just I don't have a server strong enough to compile the code in Scala that uses more than 2 parameters, let alone 7. So I'm terrified. Looking forward to it, but terrified.
Bright future. All right. So I guess now would be a good time to actually jump into code. You have coffee, I have coffee. Let's do some coding.
Before we dive in, I've just set up a very simple kind of 2-module project in SBT so that we can do both Scala 2 and Scala 3 implicit, so that we can kind of play around with differences. And there's really nothing special here. It's just...
sorry for interrupting, but when you say I set up a simple 2-module Scala project in SBT, for a lot of people this may seem like magic, but I know that you have read actually the SBT's documentation, so now you have the power.
Yeah, I spent several years not understanding SBT and getting angry about it. It's like the good old engineering stuff, why read the documentation one day when you could be angry for 5 years and not understand anything. So I did that, and then I've been a lot more confident ever since. But I do miss the times when I could just basically go on Twitter and rage against simple build tools.
Sure.
I actually like SBT now. I love it.
All right.
Yeah, it sounds weird, but it happens.
RTFM, man. RTFM.
Pretty much, yeah. So just 2 modules with different Scala versions. The Scala 2 module in the Scala 2 folder with the latest 2.13, and the Scala 3 project with the latest as of now. I think they're getting close to RC1 or M4. There's some debate on that, but this is so far the latest released Scala 3 version. And I also set up a command alias that just runs Scala 3 project explicitly. Yeah, so implicits are an interesting topic, and the reason it's interesting is because I firmly believe that Scala in general is a fairly minimal language, and a lot of the stuff that you can do in Scala, which it looks roughly exactly the same. So once you get familiar with the core ideas of the language, there's not that many special keywords. You don't have distinctions between different types of classes, and that distinction is actually going away. The remains of that distinction are sort of going away in Scala 3. So, but implicit is the one that stands out the most, just like the underscore symbol. The people that learn Scala, they get a bit horrified by the amount of underscores in your code where you just don't care. And it probably the worst way that I've ever explained underscores to people is that, oh, don't worry, just put an underscore in there, the compiler will catch it for you. I know, so that means we all know and the compiler knows, so why would you even name that variable?
Sure.
So I mean, clearly this is the way it is, and there's no exceptions, and this works perfectly every single time. But implicits are kind of in the same vein. So they're overused, as you said, for quite a few things. And the big thing that I am excited about in Scala 3 is the fact that some of the use cases from Scala 2 that became popular have now been lifted into its own thing. So it's pretty embarrassing to admit how many years of doing Scala it took me to finally memorize the magic formula for extension methods, for example. So how to write extension methods, because it's, even though it is probably part of documentation, but who reads documentation? Why would you not spend years trying and then failing? So the magical formula seems to be desktops, and then you have a value int, and then you also need to do any val to prevent allocation. So nobody explicitly tells you that you need to do that, and the language is not going to complain. So if you just remove any val completely from this, it's not going to complain about anything. And then you can say squared, and then it will just do this. So after that, you can just do, so you can do 25 squared, and it's wonderful. So squared, and it's wonderful, but also you need to remember this, and also you kind of want to do this, and then you want to do this, and it seems like this becomes an implementation detail that the compiler agrees that you know. So we both know what's going on here, and the compiler will do the thing for you. But from the looks of it, you think, well, why do I need to do this? And why do I need to do this? If the compiler knows about implicit conversions and implicit syntactic enrichments, like, why do I need to do this? And this is markedly different from something like if you have class test, which has this value, and it has the same method, right? So we do this, and then you can also do something like this. So you can say to test, which now becomes not an extension method, but it's actually an implicit conversion.
And actually, before we proceed, so I do remember, that I struggled with, this distinction between having an implicit class and an implicit conversion plus a class, a regular class. So could you maybe elaborate why would you choose one over the other?
So I think I think the mechanism is actually exactly the same. So when you're calling squared, this will be seen as an implicit conversion, and the mechanism is pretty much exactly the same, and we can probably verify this. So I'm going to remove this implicit conversion, and we can see if I can actually accept something like test ops, which is, well, technically it's a class, right? So it should exist. So test ops. So we'll just do this, right? I need to put the run on the loop. Okay, so it can't be private. That's good. Okay, and then which means that if I just do like that, it is actually the same mechanism. So it accepts it, and it actually instantiates the test ops class for you. So if we comment this implicit conversion out, and then we change this, so this doesn't compile because we don't have any way of going from integer to test.
Right.
But if we uncomment that, you get exactly the same. So I'm not familiar with optimizations that are performed specifically for extension methods, but the principle is exactly the same. So there's nothing, as far as I know, and take this with a grain of salt. As I said, it's an embarrassing amount of time that it took me to understand how to write all of the peculiar ways of doing implicit conversions versus the syntax extensions. So I can't imagine that there is a peculiar case where the Scala compiler will recognize that you're trying to do not an implicit conversion, but you're trying to do a syntax extension. In the language itself, you're just using the same tools that you would use for different case classes.
Yeah. Maybe one thing is, when you have an implicit class, can you have several constructors so that you can accept different types of objects and augment all of them?
Okay, well, no idea, but let's see. So I think it's weird. I've used case classes so much that I don't remember the last time I defined an additional constructor in a class, because I usually just put them into the companion object and use the apply method.
Right.
So this is going to be pretty embarrassing. But if we say, I think that's how you do it. Probably not. You can do maybe like that. Oh, actually, it might work. Not found value name. Update. Okay. Whatever that may mean. I don't know. It would be pretty dangerous though, because you can really blow up the search space for, like, if you have some ops defined for strings, some ops defined for integers, but they actually apply here because there's an extra constructor. So I think it should be this, like it has to be like this. Ah, sorry. There we go. So yeah, it looks like you can, which means that if we try to do test. Oh, sorry, I made something. Yeah, so what I wanted to do is do test.squared. Well, that didn't work out. I guess it just takes the primary constructor.
Right. So what if we define implicit def, the same way?
For the string?
Yeah, for the string. So that we have two implicit conversions to our ops class test. So I guess this should work.
Yeah, that compiles.
All right. So I guess this is the reason to choose one over the other.
I guess, yeah. That makes sense. I actually didn't know that. That's pretty cool. Well, I don't know if it's cool. It's probably another gun pointed at your foot, so probably not cool.
Anyhow, so I think we sort of see how to create these extension methods and this syntax ops classes.
Mm-hmm.
So as you said, this is there are several things that you need to remember and not forget to do. So how is this different in Scala 3?
Well, before we move on there, I think there are several points of confusion. So in this case, it looks fairly standard. So it's a function that basically takes an integer and produces a test. So that looks like an implicit conversion. But if we did something else, like other thing, I'm really good with names, as you can see.
It's fine.
So, and we do this. So if you look at this, whatever this is, that's not an implicit conversion. And if we look in the context of this example, it doesn't really make much sense. But in terms of implicit induction, where you're trying to gradually build up certain things, so you have another class which, well, I should have named a my thing. It's going great.
Yeah.
So you have a class myThingA, and then you're trying to do some sort of derivation for your users. So in the companion object, you can basically define that there is such a thing as myThing for integers, right?
Yeah.
myThing for integers. So you can say myThing int. And you can do the same over here. There we go. And then you can just do the same for strings. So that's all good. Empty string. So that's all good. And then what you want to define for your users is a way to go from a known instance of this class. So for example, you know how to do things with integers and you can define it in your library, but you also want to give users the ability to go to collections, for example, how to define. So that's what you say. So you do implicit def, obviously, and you say empty list, for example. And you can say that it basically takes, so what you want to produce out of this is a list of A. So it takes A, but we also want to make sure that A is not just a regular thing, but an A for which myThing is defined. So we just do this. And then you just do, I mean, in our case, we're not using anything. So you can just do it like that. So in this case, the meaning of this is very different. This is your ability to kind of create knowledge of how to infer bigger types. And the Scala compiler will look at this and it can build a chain of operations by saying, if you know how to do this, you can also do a list of this, and then it can nest as deeply as possible. So, but this pattern is very different from a definition which looks very similar over here. So it's no longer sort of implicit conversion. It's more of a kind of implicit propagation, like evidence-based propagation. So there is evidence of how to do this, and therefore you will be able to do this. So those are very similar, and the difference between the definition if we didn't have implicit over here so like this. Now that looks like an implicit conversion. So the difference is so big, and the way the compiler will work for it, that it can be very confusing to people. And this sort of inductive derivation is used so much in most of the functional libraries that we use. So like, for example, something for JSON like Circe has built-in decoders and encoders for lists, which are derived from decoders for int, strings, and etc. So, and you look at all this and you kind of memorize that pattern. But the difference between this pattern and this one is really not enough.
Yeah, I mean that's a really good point. It's really subtle. So with conversions, you have just, you know, some ad hoc way to convert one thing to another thing, and here we're talking about something, you know, closer to type classes, and the mechanism to inductively build instances of these type classes for some types from instances for another type. So yeah, I mean, and the difference is just, you know, the absence of presence of the implicit keyword, you know, before the parameters. So yeah, that's really subtle.
Yeah,
Very
and like
point.
naming wise, I feel like this pattern of implicit evidence, it sort of makes sense, but it's not like you really have to take a leap of faith to know that this explanation makes sense on the semantic level. But then if you look at this just one small example where we're not doing any magic, so we have implicit final class for extensions, we have regular classes with implicit conversions that can technically achieve the same thing, but they're written in a slightly different way. We also have implicit values that act as evidence. We have implicit functions that act as building stronger evidence, or building more generic evidence out of smaller pieces. So we have all of this and just using one keyword, implicit, which is the source of confusion, because implicits, there's probably only one place where implicits are actually bad, and that's relying on implicit conversions. So in my entire career, there wasn't a single time where I had an implicit conversion in my code base which didn't lead to a problem. So I can't find any examples of it being good, but you can see we're doing it here all over the place. We're actually not even hiding the fact that this is literally just creating a class with a completely different interface and different semantics. So yeah, it exposes too much from the language internals.
Right. So basically what we have here is just, you know, like implicit conversions, extension methods, type classes, and inductive type class derivation. And you know, all this just by using one keyword.
Pretty much, which is the problem.
And it's easy to see how this is confusing. So how this was improved? Are we ready to talk about Scala 3?
I think we are. So if we switch to I probably should have an empty file. So I'll just do givens in scala3.scala. Well, I shouldn't have done that. There we go. I actually don't need this top level object. So as I alluded to, the implicit is overloaded. So we're going to talk about several things that have become language constructs, and we're going to talk about ergonomics of them. So the first important thing is that you can still do pretty much the same things. And the implicit keyword is very much still there in the language until, well, at the very least 3.1. So it's there for backwards compatibility and just in general to ease the migration, because the whole big thing of Scala 3 is to make sure that, you know, it doesn't repeat the Python 2, Python 3 fiasco, and that people can migrate their code bases to using the new compiler, but not necessarily using the new syntax, given that it's a major rewrite. So
yeah,
I think unless I need to add some flag to this, let me just delete that file. I didn't want it here anyways. Okay. Cool. So you can still do implicits in Scala. So we can say implicit val. Let's define something. We're going to call it context. So you can still do context. Yeah, why not? And you just have this, right? And then we need a main method. So hello, Scala3. And obviously I'm going to use optional braces. The discussion on it is heating up even more than it was before, so it's only fitting that I'm going to use it.
All right, go for it.
Yeah, and we can do test, which takes, again, implicit context. Oh, no braces, no braces in this video.
Alt-Tab is die hard.
Exactly, yeah. And we can do this, and then we can do, yeah, so we can just do like that. Cool, so you can see the implicit is still passing through, so that's all fine.
Right.
But obviously, in Scala 3, there is the two new keywords, given and using. And to go back to my point about that semantic leap of faith, where you have to accept that idea that something about implicit evidence kind of makes sense for most of the usages that we've seen, but you need to make that leap to make sure that it convinces you. So given and using kind of, in my opinion, makes it a little bit better. So let's rewrite our example. So the first thing, we're going to talk about something which is like dependency injection style sort of thing to simplify the number of parameters. So we're going to have F1, which will be using context. So all of them should be using context, but only those methods will be using them directly. So we're going to say it's actually using context. And we can just say, hello, context. We have this F1 and we have F2. Right, so we've got this. So you can use that using keyword in places where you used to use implicit. And then we're going to rewrite our functions like this, F1 and F2, which works. Both of them work, so the passing kind of works. But in this case, you can see that test itself doesn't actually care about the context that much. So what F1 is requiring is that it's invoked in a scenario where the context is available. And it kind of creates those scopes of things where you can call F1 and where you cannot call F1. And same with F2. So the invocation of test, because it takes an implicit context, creates the scope where invocations of F1 and F2 are valid. So valid from not the language point of view, but rather from kind of business logic point of view. So, but it doesn't use the context itself. All it does is just organizes two different things that use the context explicitly. Say we use this context for logging or for, metrics and whatever. So we don't actually need to name it anything. So we can say, yep, it's using context. That's still working. And then we can just remove the name, because like naming things is difficult. And why would you ever do that? Yeah, so in this case, we can use the unnamed context parameter because we're not doing anything with it, but we're rather identifying that whatever is inside of this block where test is being executed is safe enough for F1 and F2 to actually execute because the context is available. And in this way we can separate things. One of the actually nicer examples that I've seen in Scala Native, which hopefully is going to get Scala 3 support soon, but the way it's done there is you have a thing called zone, and zone is you have methods, so we can actually rename this to zone.
Right.
You have methods in here that take zone, and zone allows you to allocate memory, and then it will keep track of those allocations and then free them up. So what you do is you basically create a new zone somewhere where you can create an implicit instance, and then you can call F1 and F2, and those functions F1 and F2 can call this zone parameter and ask it to allocate some memory. But this scope, and that's actually I think one of the better representations of what I'm trying to say, this scope is safe for allocations because by the time the scope finishes, implicit zone parameter will contain a chain of all the allocations, and it can free them up in reverse order, which means that you can safely allocate inside of those methods. And when the functions are being called with an implicit zone, they don't need to worry about locking or finishing and freeing the memory, because they are executed in a context where it's safe to allocate. And that safety is represented by the fact there's an implicit zone that you're running in some limited block where allocations and deallocations will be taken care of.
So this is actually, it looks similar to like the concept of memory arena, right? And it's a similar thing basically when you have, let's say, some code that is kind of allocating a lot of stuff, and then when you're done with this code, you can just free all the memory in one batch. And this is much faster than when you just use dynamic allocation, because you don't have to keep track of all the blocks that you have allocated that you need to deallocate. It's one arena that you just basically destroy after you're done with it. And the allocation is easy because you can just bump the pointer within the arena, so it's like a throwaway part of memory. But one thing that I'm curious, it's a little bit it's a small digression from the implicits, but maybe so with the zone, I believe that the allocation should happen when the zone is destroyed.
Yeah, so the way it actually does it is whenever you call allocate on the zone, it creates a chain of nodes, which basically each allocation creates a new node in the chain, and then after the zone is finished. So pretty much this apply method, once it finishes, it's going to go in reverse order. It maintains this track of allocations as a kind of basically a linked list, and it's going to deallocate everything that was allocated in the zone.
So it's right after the apply, sort of.
Yep. So everything in here can just do whatever it wants, and then once it finishes, so you can then return the result. So I've used it for some like data processing where I just use C library to do stuff, but I pass through the implicit zone as it's the evidence for the methods that it's safe to allocate, and they don't need to free stuff anywhere, and then everything is taken care of.
I see. First I was a little bit confused, because my initial impression was that the memory will be deallocated when the zone object is sort of destroyed, but in like this GC language, it's not really clear when the zone object will be destroyed. So now it makes sense. Awesome. So getting back to the implicits.
Yep. So we're just going to rename it back, and what we're going to do is, first of all, you can create an instance, basically GTX. All of them have to have, so my metals is being a bit weird, but all of the implicits have to have explicit type, which is ironic. So all of the givens have to have explicit type, and that's actually something that is enforced by the Scala 3 compiler all over the place. So in some of the code bases, you could see a lot of code that is basically doing implicit conversions without specifying the return type, which means that if you change the implementation of the implicit conversion, well, you know what happens basically. Because
that's
not only not only are you using a very dangerous feature, but you're also making that dangerous feature even more terrifying, because it can change in any way you want. So explicit annotations all around, basically. But what about, so let's just call this logger, right? Because it's a simpler example.
So you'll keep using the same variable, but with different names.
Pretty much, yeah. I mean, as you can see, I'm well prepared for this, so we're just going to use the same thing. And we're going to define our class logger, which will just do message, and then it's going to take a level and whatever. And then we're going to say that it just prints this. Like this. And I ask forgiveness from the FP gods for using toString, but you know.
Let's maybe just amend this real quick and introduce the type class show.
Okay, fine. Okay, we're gonna do that. You're gonna make me do this. Fine. Okay. So we're gonna do type class, which will have a show string. Okay, and we can do. So it's gonna take A, and all it needs is show of A. So that's that. I'm gonna. That's it. I'm going to call a method called summon. So in Scala 2, you could use a method called implicitly to give you an instance, but in Scala 3, it's named summon. Basically, all of the usages of the word implicit are now considered cursed, and you're not allowed to use it anywhere.
So we're using summon instead.
Summon, yeah, like summon and
sure.
curse. You know, it makes absolute perfect sense. So yeah, you can call summon, which will give you an instance. It's exactly the same, and honestly, most of the time the pattern is actually a bit different, so people prefer to do this, and I personally prefer to do this, is by defining an apply method, which will take show instance and just return it. So I actually prefer this pattern quite a lot because it makes more sense. So in this case, we don't need to do this. Actually, that's a good point about the show, because then we're going to show extension methods on it as well, which is good, which is better than my example that I had. But
Teamwork.
For now, yeah, we're going to do, so we could have named the parameter over here, but we're not going to do that. So we're just going to show A and do this. Okay, so that this compiles, that's beautiful, because we're not calling any methods on it yet. Oh, no, that's all fine. Right.
Wait.
You saw that?
Yeah.
Okay. So how about we define some instances? So show string. The syntax changes so much. I'm going to define it first and then explain what's going on. Something like this. Oh, yeah, okay, that was silly of me. Obviously, we actually need to take the value. Okay. So this will just return it. Okay, so this is, this is like a slightly shorter syntax of defining an instance of the implicit value, because in the Scala 2, you would have to do implicit val show string, which has to be a show string, and then you would do new show string, and then you would define those methods. So you don't need to do that, and the magic formula is given and with, and then you can just write the definition in line, basically. And
if you have like several methods inside a type class, you just define several methods on the with. I see.
Yep, we can do show new lines. Value A, and it's going to be this, and we're going to define it as just adding a couple of new lines to the output. Well, I shouldn't have done that probably, but okay, we can just override this in a way. So we can do show new lines, value string, howdy. And now it's broken. Oh, yeah, you just need an override because I provided the implementation. Right. So you can still do the same exact thing. It's just, Java just opened for me for some reason. Right, okay. So in this case, we actually don't, because Haskell has type class coherence, and I'm sure you're going to be able to tell me a lot more about it. In Scala, there is no such thing, but you can make it look like there is some by not naming those parameters. So it looks like a global instance because you don't need to.
Oh, wow.
In a way. Yeah. It's still overridable.
Since you have defined it within a companion object, it will be available at all call sites.
Yes.
I see. All right.
We can actually test this. So what did I want to do? I wanted to do show string, and I wanted to show it hello.
Yep.
Yep. So we have it. And if we do show int, yep, that's an error. No implicit argument. So it is available, but I think you can still override it. So we can do given show string with and we're going to call it, yep, there we go. So it still works, and there's no coherence per se in this scenario, even though in both cases we just used anonymous instances, but obviously you can override them in the nearest scope that you have.
Right. So you still need some form of code convention within your project to try to avoid this. But I mean, honestly,
yeah,
in my practice, this was not a problem. So I mean, maybe someone was, bitten by this, but not me.
Yeah, like the only issue is so that was present in the CATS versions, like 1.0 all the way to 2.1, I think, where the instances for the built-in standard library classes were not put in the companion object. They were actually imported separately. So you would have conflicts because technically two things can match a particular thing that you're trying to call, and then it would actually complain, and you would have things like both instances, cats, std, instances, list, either, and this thing match. So, which is probably impossible in Haskell, but since the version 2. I want to say basically latest version of cats, all of those instances are put in the companion object, so you don't need to do any extra imports, like no more cats implicits dot underscore. So which simplifies things quite a lot. Cool. Well, actually, yeah, let's test that this logger works, because I did not test it at all. So we have our logger somewhere. We call it context because I'm reusing everything. And we can say message, info, and then we're going to say hello. Yep, so that works. Did I do print line or print? Oh, sorry.
I guess you need to call
weird,
show on
right?
the string.
Oh, yeah. Oh, I was so excited. I thought it was a bug in the compiler. Okay, so it's not. Whatever. So we're just going to do to differentiate from the SBT's output.
Nice.
There we go. So we've got the hello. So yeah, you can still do this. You can name the parameter if you wanted to. You can also, the context bounds still work. So you can do a show and just remove this completely. Exactly the same thing. So because this, I think this is one of the nicer patterns that I've used. I really like context bounds for simpler things. And in our case, yeah, that makes sense. And then we can, because it's top level definitions, we can just do things like define info, and we can say message S is A, and we do the same thing. And we're saying that we're using logger. And now that it's because it's a top level definition, you can just use it everywhere you want rather than trying to import it from anything and whatnot. So log message, 1 sec, and we can just do info and then S. Okay, so now that we have this message set up, we have our givens and whatnot, let's talk about the extension methods. What we want to do is to make this pattern a little bit better. And in the Scala 2, you would be using implicit class, which would be taking an implicit instance of show and then creating that method string that you can call in a string itself. So that what you want to get to is something like this as show. Obviously, this doesn't compile right now. So let's try to add it And let's see if by adding it, we're going to face some issues. So, foreshadowing. Right. So the new syntax for adding extension methods, as I said, it has been lifted into the language itself. So it became more of a first-class citizen in this case. And there's a new keyword called extension. What I haven't checked is actually whether it's a soft keyword or not. Let me just do this. Extension equals. Yeah, so you can still use it. So the compiler will try to disambiguate where you mean extension as a variable or where you mean extension as a keyword. Yeah.
I mean, to be honest,
there's quite a few of those.
I mean, I haven't seen soft keywords before, to be honest. So this is interesting.
I mean,
interesting.
I think as is one of those as well. So 25. Yeah, still works beautifully, even though it's used in. I think it's used in the pattern matching, and maybe it's going to be used in the imports. Imports is still being discussed. But anyway, back to the extension method. So what we want is an extension, and at this case, like at this point, you basically define the sort of value that you want the extension to apply to, and then you can define all of the extension methods that you want on it. So we can just say that for any, I'm going to call it value A, you can define an extension method. And the funny thing about it is that for some reason you don't need, it's not a block per se, and it's not really a definition either. It's just, I think, a way of marking the methods as extension. Then the compiler does kind of rewrite rules on it depending on where the extension method is located.
And what if you are not using optional braces?
Right.
Do you need to have braces with extension or not?
I think you can. So I think you can do this. Def expected. Yeah, so it's expecting a definition at the very least. So when you're marking something as extension, but let's try it without the optional braces. So with required braces.
Yeah.
So what you want to do, and you think, okay, I'm going to do this. So what you want to do is basically delegate to this method. But here's where the problems lie. What you're getting is that it's saying that there is a double definition of the two things. So you can solve this by we're going to compile this and then make sure that we check out the bytecode just to see what it looks like in the actual compiled bytecode and see where the problem actually arises. So let's call this actually apply. Rename it over here and over here, and then we can do this, which is great because now it works. So we have an extension method defined on the trait itself, which delegates to the apply method over here, and we can use it. So that's all good and dandy. So let's see if we didn't use the apply, not this one. So let's go back to show. Actually, no. So we've got the apply. So let's take a look at what the bytecode actually looks like. So I've got the bytecode over here.
Yeah, and maybe before we jump into the bytecode, could you show how exactly you generate the bytecode? I see that you have some nifty script. So would you mind?
So there is an extension for Visual Studio Code, which allows you to, you can basically install, it's called a Java bytecode viewer. But what we realized is that if you don't have the extension, then, or actually in any way, you cannot watch the bytecode and have the same experience of us navigating through it together using LiveShare. So instead, what I did, I wrote a simple Ammonite script that I have over here, which I'm gonna clean up ever so slightly and publish on Gist somewhere, because I think it's useful, especially when you're playing with Scala 3. And it's basically just Ammonite script, uses parallel collections, and for each of the files that it processes, it just calls the Java P command. So the Java P command is the thing that actually does the disassembly. I mean, I haven't done anything in here that merits any sort of, effort or excitement from people thinking, oh, how has he done this? I just literally shell out to Java P. And to use this, I'm working with the exceptional library called Ammonite Ops. So I'm using it to call processes, I'm using it to manage paths, I'm using it to walk the tree of the files that can and just select all of the class files. and I'm basically dumping. So in one of the terminals, I have another one, which is just running Ammonite Watch. Okay, yeah, so it's running Ammonite Watch, and it processes all of the files. And the cool thing about it is that you can tell Ammonite not just watch the script itself, you can also tell it to watch a particular folder, and for any of the changes, it's going to restart. So that's what I'm doing. This is a very simple script, and it dumps everything into this folder that I specified myself. And you can see every time it recompiles, it will just delete everything and run new, so you don't have the stale bytecode. So for the current example that we have, that's exactly the bytecode that is produced by the Scala 3 compiler.
Nice. Maybe we could actually attach it as a gist in the description.
Definitely, yeah. I'll just put it out. It's very simple, but it's quite useful to understand how those things work. Shall we look at the bytecode?
Yes, let's do it.
So the first thing we're going to take a look at is, so in the logger method, we basically call this s.show on a string. So what does that translate to with the extension method? So if we look at the logger class itself, we can see that the method message is actually invoking a method on the show itself. So can you see line 103?
Yes, finally.
Yes, show.show. So it's invoking this interface method on it, and what is it passing to it? Show me your reading skills.
Regular object and getting a string back. So
where does it get the object from? Okay, so it's actually, is this what it is? The ALoad3, is that loading the third parameter into the stack, or whatever? Okay, so it's invoking the show instance that it received, and so it's putting the, why is it taking one parameter? Is it actually taking one parameter?
I think that what we have here is, so we have the show instance on top of the stack, and then we invoke like a show.show method on it, and the argument is the object that we want to show.
Right. Yeah. Okay. Okay. Cool. So let's take a look at what show actually does. I'm going to look at the bytecode. I'm going to change the hello to this new bytecode. So this is from show.bytecode. So this is the type definition of our thingy. And it contains a show method, which takes a single a parameter.
Yeah.
And then it invokes, it delegates to that apply method that we defined on the instance. So that's what we've got. I'm also seeing this show,
which is a static method, actually.
Yeah. So we have two.
Right.
Is it actually being used anywhere? Okay. I think this one might be. So you have the extension method defined on the show itself, which this, I guess, the Dotty compiler kind of processes it as a show method that you can call on the instance of the show type class itself. And then you have another one, which is a static method on the show object, which was rewritten into taking as a first argument an instance of show, and as a second argument whatever the object you want to call on it. So and that's how it rewrites it, because if you look at the definition of the second method, the show with a $, which is a static method, it's actually calling the show method on the what is it? Yeah, on the instance itself. So they kind of delegate to each other, basically. So you have a static method that can take any instance of a show type class, and it will take the object on which you're trying to run it, and it was rewritten into passing that to the show method on the type class definition itself, from the looks of it.
Yeah, so what is interesting is that basically here the extension method is a part of the trait. Basically we have method show, which is an extension method defined as a regular trait method, and the usage of the syntax is actually rewritten just to call an instant method on like a show instance provided to us. So yeah, we don't actually have any like new classes or any conversions happening. This is much more straightforward in terms of, you know, what's happening in the bytecode, if straightforward is the right word to use here.
Yeah. With the exception of the fact that we actually had to rename this. So I'm not sure if that's a bug in the compiler or what, but as you can see, us trying to do a normal thing of calling the show method, you see some confusing errors. You have the double definition, and then that double definition is, it sort of makes sense, because if this is being rewritten as an interface method on the type class itself, then they would be conflicting. Like, that makes sense. And as I looked into this, I thought that there is a special annotation. So there's an annotation over here designed for disambiguation. But in all honesty, I could not use it properly. So it's called target name, which seems to be designed for those specific cases. And I thought that you can just do target name and just do ext show, which doesn't seem to work for some reason. Maybe the idea was that in the bytecode, the extension method is supposed to have a different name so that at least it's disambiguated and that there's no double definitions, but it doesn't seem to be the case in this scenario.
But also, it's just not clear how to actually, you know, here how to refer to the traits method rather than the syntax method. So we need to somehow disambiguate between the two and also make sure that in the bytecode the names are different. So yeah, it's not very obvious, to be honest. But I guess another thing is that you can just move the extension out of the trait, either at the top level or to the companion object, but then you have to import the syntax, which is not necessarily a bad thing. So
it's often a good thing, like syntax. And so going back to the example that we had with cats, is when all of the instances for different type classes were moved to the companion objects, you didn't have to do implicits anymore. It was lovely. But the syntax itself, it's imported. And the reason it's imported is because it puts so many methods into your scope, and you want to kind of control that occasionally if you want to make sure that you're not calling a method with exactly the same signature but with slightly different implementation. Like, imagine if you had something which was like non-tail recursive and you had a tail recursive implementation of something, and then you call one thing or the other even though they're named exactly the same. So I guess that's not a bad thing. I'm still confused as to whether this is a bug, that when the trait is being rewritten, that you get exactly the same method. Because I hope that whoever watches this can actually shed some light on how to fix this particular example. But going back to what you said, to make this a bit more obvious and see how it's different from the case that we had before, because that was a simple case. Like, you just add a method on the show trait, you have something that invokes statically, beautiful. So you can move that to top level, and in this case we obviously don't have a way of accessing the show instance directly, so we can just make a type parameter over here. Now we have no way of showing. Actually, are you seeing this type mismatch error in the terminal by any chance? Because before that you didn't.
Yes, I do see now.
Do you see that required int thingy?
Yeah.
Can you see it?
Yes, now it's perfect.
Okay, lovely. So that strange error with required int, I also don't understand it. But what it's trying to do is, we don't have a way of actually invoking the show method. So extension methods can be defined in roughly the same generic way. So you have the same evidence-based system. So you can say, I'm using some instance of show for A. So I'm saying that define this extension method only for those that have an instance of show, and then we can call it like this. And that works.
Yeah.
So that's lovely. But I believe the bytecode for this would be slightly different. So the bytecode for this is quite interesting because now that it's a top-level definition, it has to live somewhere. There's no top-level definitions apart from like classes in the JVM. So it has to live in an object, in a class, or somewhere. So if we look at, I'm going to copy and paste, it's easier, into the hello bytecode, unless you can see it perfectly.
So it's a good question. So where are you at right now?
Line 96.
And you see string show a.
That's the one. Yep.
Okay.
Yep. Cool. That's the one. So so this is a static method defined inside of the package object. So if you remember from the previous time, the type level definition, the top level definitions in the Scala 3 are put into this new synthetic object that is created for you, which is based on the file name. So the file name is actually given, say, in Scala, blah, 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 blah. So that a static method was created, which takes two parameters, a parameter A and a evidence of show of A. And that's when it basically invokes that method on it. It invokes show on that instance. So that's simpler, but it's put into the companion object. But it still works for us, right? So it's and now there's no ambiguity because the compiler didn't have to generate any method on the show's interface itself. It could just create a static method on the package object, which takes using the given explicitly. So that simplifies things with regard to the conflicts. And a third way of doing this would be something like this: show ops. We can create a trait where we can define everything, and now the compilation is going to fail because this extension is not in scope. Like that trait just exists somewhere. So what we could do is basically do this: extends show ops. So we have an object with the syntax, and we can import that, right? So that works. Or we can just bypass this and do something that looks super weird, and I really hope that it's not going to be used too much, but we can say something like this: show ops with this. So what this is doing is putting the show ops, an instance of show ops, into the implicit scope of this current file, basically, because under the hood, the resolution methods for the extensions, they are based on either being defined on a trait itself, on the type class trait, or they're defined in some implicit scope, or they're defined on the companion object. So, and in this particular scenario, whilst the result is exactly the same, we kind of face the same issue as we had before, because now show ops is an actual thing. It's an actual class that was created. It probably has, it has a static method that takes 3 parameters. Show ops, because it was created. I think it just takes itself for some reason. I don't know why. Maybe, I don't know why actually. Like, no idea. Oh, well, maybe because, you could do something like this, and then, because technically you can't do that.
Right, so you need an instance actually to invoke.
Because it could be referencing something inside of the show ops. So once it's instantiated, it needs to call itself. And I guess if we take a look, it's invoking something. Actually has 2 methods, static one and a default one, and one of them probably delegates to another.
All right, so we have talked about extension methods. What's next, Anton?
So the next thing we're going to talk about implicit conversions. We're going to talk about them very shortly because, as I mentioned before, implicit conversions don't have, in my opinion, many places where you can actually use them, or where it's safe to use them. So with that in mind, Scala 3 does introduce new syntax for defining them, because as we mentioned when covering the implicits in Scala 2, the syntax for defining them is something like convert to string, and you define an implicit function which takes a parameter and then return value, and we can say, yeah, hello int b. So this is the syntax for defining an implicit conversion. And we mentioned that the difference between this and just adding implicit dramatically changes the meaning, because now this integer parameter acts as evidence rather than an implicit conversion from int to string. So
yeah,
to make this more explicit, in the Scala 3, a new class was introduced, and the class is called conversion. So we can actually define it over here, and we're going to use the new syntax for this. So we're going to use an unnamed conversion parameter, and that's how you define a conversion, which does exactly the same thing. So it's a instance of this conversion class with a single apply parameter, which takes an integer, returns a string, and then we can just copy whatever we did over here. So this means this is how you define implicit conversion, which is more explicit for people reading it and also more explicit for the compiler to detect. And there are some better defined rules in terms of where that conversion can be applied, depending on whether it's a return parameter or whether it's like if you're calling a method on a particular object, the compiler will be able to kind of explicitly check, is there a conversion going from this type to the type that has that particular method or that particular property.
Right, but just to clarify, like we still can define conversions using the old syntax. So in this sense, Scala 3 is compatible with Scala 2.
Yes, there's a lot of stuff regarding the implicits. As you can see, the word implicit did not go anywhere. And in the official documentation, even though it's using mostly givens and using, it still makes a point that until at least the version 3.1, the implicit syntax will still be available and will be unified with the implicit mechanism in Scala 3. This is to avoid compatibility and ability to migrate the libraries, because it's important, like the syntax changes are not as important as verifying that the new compiler, which is what Scala 3 is, actually compiles the projects, tests them, and generates valid bytecode for all of the projects. So, but those small things, implicit, they are still available. And we can actually, demonstrate this by, let's do test conversions. And we're going to define a method, test me, which takes a string, and it's going to basically check if that string contains hello. So it works obviously for regular strings, and because we have an implicit conversion in scope, it's going to work for integers. And if we run this, what do we call them? Test conversions.
Right, yeah. Looks like it worked.
And you can see actually both of them are available, which is strange that the Scala 3 compiler does not complain about the fact that you have technically conflicting things in the scope, but also it issues a warning for you saying that you need to explicitly enable implicit conversions. And you can make those warnings a compilation error just to make sure that you didn't write some code that accidentally got interpreted as a implicit conversion. So if we just
just to clarify here, so we have two different conversions. One is a conversion method, another is a conversion object, and they are both in the scope. And one of those methods, one of the conversions, got applied. Which one? Let's maybe test this.
Yeah, let's test. That's a good point. So we're going to do testing the string. I added this import just to shut up the compiler.
Right.
And we're going to do this implicit conf. And this one is going to be given conversion. Let's take a look. Yeah, so the given one got applied first. I wonder if it's order related. Nope. It still picks up the conversion first from the looks of it.
Huh, interesting.
Yeah, so it works either way, but the conversion is given precedence to the implicit function that we have.
All right. Good to know. Although it is, I would rather have a warning or better an error when I have two different implicit conversions, because I mean this is I mean conversions are already dangerous, and now you have this, which is just insane.
Yeah, I kind of agree with you here. I did not know that those would be not even conflicting. So the compiler is completely quiet about the fact that you have two ways of going from int to string. It's not quiet, it's shouting at you for using implicit conversions without the language feature, but it's not actually shouting at you that you have two things that can do the same thing in scope. Yeah, interesting. But at least it applies the conversion first, so, you know, I guess that's good. I don't know.
So there is a method to this madness, yeah?
I think so, yeah. Like the rules that are outlined in the Dotty documentation are very clear on when the conversion gets applied and why. But it doesn't clarify the fact that you can have two in scope and it's going to pick conversion first. So oversight, I think, unless it's for compatibility reasons again.
All right. So with conversions, it's more or less clear.
Yep.
What's next?
So we're going to kind of expand on this one, and at the moment we're defining the conversion in the top level scope, which means that everything in here is going to be subject to this conversion as long as you enable that feature. The problem is that this is sort of now package level implicit conversion, and this is not something that you want to go about willy-nilly and just basically pop it in the scope and apply everywhere. Gladly, the implicit conversions feature is going to tell you where you're doing something wrong, but still. So what Scala 3 introduces is the ability to control imports. So if we were to put this conversion into an object called dangerous, because, you know, let's face it, that's what it is.
Sure.
First of all, our code no longer compiles because that given conversion is no longer in scope for the method test_me or test conversions. But second, we can now import it. And that's where I want to verify something. So in Scala 3, you can now separate the imports of regular members, so methods, variables, values, whatever, classes, and etc., which can be imported separately from any given instances, which applies to given conversions as well. So in this case, if we just do import dangerous and we just import everything, this still doesn't work. So we're using the good old underscore import everything, and this doesn't actually put this conversion into the scope of the method. And the compiler itself is complaining about the fact that there's still no way of going from integer to string, but it also suggests that there is something you can import which would allow you to do so. And I think in the standard library there is some numeric widening implicit conversions defined, which is dangerous if you're doing kind of number sensitive code, but most of the time it's okay. And you kind of want that instead of going like too long all the time. So to import that given conversion, we actually need to do this special syntax, which is dangerous import, and we can import given. And in this case, it will look at whatever the implicit or rather given instances that the object has, and we can import them separately. And we can also import them by name, because like at this point we're using a nameless parameter. So if we just give it to string, give it a name, and then we can import that directly like this, and it works the same way. But by default, if you just do underscore, it's not going to put that implicit conversion into scope, which is very nice for when you're looking at the imports in your particular file. You want to make sure that you're not accidentally importing something dangerous in scope, because whilst you trust the library to do the right thing, the exact interplay between your code and the library code and the implicits that it uses might be dangerous. So being able to control that is nice, and you can combine them So if we have this fail method, which we'll just throw, actually, I think I can now do this. I don't need a new keyword. Of course. Beautiful.
Finally.
So, yeah, exactly. So at this point, I want to import all of the regular members of the dangerous object and also all of the givens that it defines. So I can just do this, and I can use both the implicit conversion, but I can also do, I can also use the fail method that was imported.
Right.
So this gives you a much better control. And I think actually this goes a bit further. So let's define a trait called divisible, right? And what it's going to do, well, it's not going to actually do anything. So 1A, 2B, and it's going to basically allow us to divide things, right? So I think, and we're going to verify this.
And what's the other type parameter B? Is it part of the trait definition or?
Oh, sorry, that was a mistake. Good spot. Yeah.
Okay.
So, given divisible int with, and we can just say divide 1 int, 2 int, and it's going to be 1 divided by the other. So now that we have this, I think we can do something like this. So for example, what if we wanted not to import all of the givens in the particular scope? What if we wanted to import just the instances that we know that our code uses? So I think you can do something like this, maybe. Yeah, I misspelled it. There we go. And that's beautiful because now we are not importing all of the methods. We're not importing the conversion. So let's just remove this and make sure that we actually get that. So divisible int, divide 25 by 5. Nice. So we have this, and we can import by type, because implicits are like, they used to be quite strange. They are indexed by type, but also in the Scala 2, they could shadow one another because you have them kind of defined in the nested blocks. So most of this stuff, as far as I know, has been fixed in Scala. And now there is ability to infer particular terms, or rather import particular terms indexed by type, which I think is very nice. So your imports can tell you a lot more about the code and also make the compilation faster, because one of the main problems with compilation in implicits heavy code is that you kind of need to have a lot of stuff in, and occasionally with things like generic auto derivation, in full auto mode, you need to import and then it puts that macro deriver for everything in scope. So the compiler needs to do a lot more work to figure out what exactly you're actually using. So in this case, you can import them by type, which I think is a very nice improvement. Yeah. And just having this division between the two is also very nice.
Yeah, it's actually interesting. I just remember that, let's say in cats, there was this very careful arrangement of implicits and traits extending other traits so that, you know, the right shadowing is in play, and the sort of the right implicits are in the scope. And maybe with this, like, you know, this smartness will not be needed anymore, and you can just express things more naturally.
Yeah, and I mean, in the more recent versions of cats, a lot of the implicit instances were put into the scope, and that was done very carefully because of the way the scope is being resolved, and with regards to subtyping as well.
Yeah.
Because that's one of the things that, as far as I know, Haskell doesn't have, and which might be a good thing or a bad thing, but subtyping for type classes is a thing that cats takes advantage of quite a lot.
Yeah, for sure. I mean, sometimes, let's say, subtyping is really handy, and sometimes in Haskell you do want to have some sort of subtyping, and to be honest, there is some sort of subtyping between functions, at least was, but yeah, I can see how this is much more difficult when you have, you know, like a system with real subtyping. You know, one thing that I would like to confirm though is, so we have this blanket import, the underscore import, and it doesn't import the like a conversion object by default. But what about just a regular conversion method? If you have, you know, a regular implicit conversion method and you do this blanket import, will it get imported or not?
Okay, let's test that out. So what was our thing that was using it? Let's see, what was the method? It was the same, conf to string, was taking a number, taking a string, and I was just saying blah. Yep, so it's still not imported. So at this point, they're treated exactly the same. And I think like if I can do given conf to string, I think I need to do something else. So this is syntax where I actually don't remember how to do that.
Maybe you cannot use the wildcard.
Well, actually, I guess given that's interesting. So if I remove this compile, this doesn't compile.
What about just
right?
conf to string?
Sorry. Yeah, like it's the indexing stuff because it's indexed by type. So I can do this. Yep. So I can do this, or I can do directly reference that. So conf to string, this one. And I think both of them are going to work. Yeah. So if using the given import, you have to verify and provide unambiguous type, basically, to import that particular thing. So does that answer your question?
Yeah, but I mean, as far as I understand, if you just do the wildcard import, by default, this function is not in the scope, so you don't get the import.
Yeah.
Just like this.
Sorry.
Or actually it is.
Well, yeah. That's where we get into that situation that we kind of covered. Like, I don't know what are the resolution rules between an implicit def function and a given conversion. But it's probably safe to say that things defined using given and using they work safely with the new language features, and all of the implicit defs, because like if somewhere in your code you actually have this import and your code is using Scala 2, this exact behavior is exactly what you would expect. So I believe for compatibility reasons, this is still doable. But importing the conversion doesn't work, because like if you went through the effort of redefining some of your code in terms of the new Scala 3 functionality, that means you're more likely to have done the effort of properly separating your imports and doing all of that stuff. But the rest is left as it was to ease the transition.
Yeah, I mean, and this actually makes total sense. Maybe the last thing that we could cover here is, the how can we use implicits to actually build DSLs?
Yeah, that's a good one. DSLs get a really bad reputation because when DSLs work, it's beautiful and it's just so gorgeous and Scala really shines. But when they don't work, when the DSLs try to do everything for you, like build string names, for example, for tests, that's where I personally get quite annoyed with them. So, but I still think that DSLs have a really, really, really good place in the Scala code bases, but one must exercise restraint because it's easy to get carried away. So let's see how we can get carried away.
Yes, please.
Yeah. So let's do.
Yeah, I mean, that's kind of the whole idea, right? Let's get carried away.
Yeah. Let's basically make something that I would never use in my life, but I mean, in this particular situation, but it looks super cool. So let me just comment this out so nothing breaks. Cool. I'm going to define this new function. And I named the file implicit functions because that's exactly what we're going to use to demonstrate the DSL part. And we're going to demonstrate a couple of other tricks in the Scala 3. So what I want to do is to build a DSL which looks like a testing framework. We're not going to do the actual runtime implementation of it, but we're just going to show how enforcing some sort of structure in our DSL using implicit functions and ability to negate implicit search. So we're going to see how we can do that. And in the most general sort of sense, I want to be able to do something like this. So I want to do some spec. And then in that spec, I want to be able to define test cases, case 1. And in those cases, I want to do assertions. So I want to do should be positive. And this is just to verify that we're living in the proper reality, that 25 is still above 0. And what I want to do is also add something like before all, which will be just like a setup function, setting the rocket up. So we have something like this, and I want to do nothing other than implicits and new Scala 3 features to enforce this structure. So the assertions can only be inside of test cases, not in the group itself. The before all block should have to be in the group so that the whatever framework we're using can actually pick it up and run those setups. And we can actually probably define after all, because it's going to be exactly the same thing. So just copy paste it.
Okay.
Disassembling the rocket. And to do this, we're going to use implicit functions. So implicit functions they come with a new syntax, but we also sort of saw them already in Scala 2. So in Scala 2, you could do something like, if you had a function that, do we still have class logger? Yeah. Okay. So if you had some sort of function that was doing some stuff with the logger, and you just call it, what you could define, let me just comment this out. Class logger, yeah. So I'm just going to keep it there. So if you had some sort of logger, you could just run your functions with the new logger. So you can just pass it in, and that was beautiful. Let me just change this like this, because it's conflicting with our other stuff. And then when you define some sort of usages of this function, you could have said something like verify, and you would basically use an implicit logging context, and you have like lots and lots of those functions. So lots and lots. Well, 2. So in Scala 2, what you could do is basically create some sort of a block which would take this log context function and define it using an implicit parameter. So you can say that my test is something which calls this function logging context, and the logging context is the one that is actually responsible for creating the logger and doing whatever. And it takes a function. So in the previous scenario, you would have had something like this, and then it would be annoying to do like implicit val lctx, log ctx, and then you can do verify and verify 1. So you would still have to do that. So this particular pattern, in Scala 2, you can just say implicit, which means that the parameter that this function takes will just go directly into the implicit scope of the block of this function. And if I did everything right, yeah, it compiles. So you can still do that. But the problem is that this signature is just of a regular function. It doesn't indicate that there's implicits going on. So you have to do it in the definition of the function itself. So, and it's kind of harder to compose them in that case because you always have to do this. But gladly, well, Scala 3 adds a new type, which allows you to define an implicit function in the type signature itself. So we can say that our thing with the logging context is a function that takes log context, but it doesn't just take it as a parameter. It takes it implicitly and then does something and returns unit with it. So with that in mind, the Scala compiler will recognize that what you're expecting here, and this is the magical bit, that question mark is the magical bit, which makes this function an implicit function, which means that you can just omit this altogether. So if we amend the signature over here, we're just saying with logging context is going to be taking an implicit parameter, and now okay, so we can just do using logger. Nice. This is actually, yeah, this is one way that you can use the givens and using in Scala 3. You no longer have that problem with multiple parameter lists and like you need to specify the correct location. You can override implicits quite easily by just using this keyword using and just passing them directly. So if I did everything right, I think this should compile. There we go. So in this case, this looks much nicer, and this looks like the beginning of a DSL because we're still passing this log context state. We still have the full ability to control invocation of the function that uses it. We can control what instance is going to pick up, and also we don't need to explicitly specify it or pass it through because the compiler just resolves that the parameter is only used implicitly in that function. So with that in mind, going back to our old thing, we can define some things. So I'm going to remove all this, and I'm going to define a class called group context, which in our scenario is going to be something that registers the things that you need to do, the setup, the starters, the finalizers, and it's going to also register all the test cases, and then eventually submit them to the testing framework.
Okay.
We also have a testing context, which will be representing the state inside of the test, because we want to register all of the assertions for that test. So we're going to call it test context, and I'm not going to provide implementations over here just to avoid this video running 2.5 hours as I struggle with this. But now that we have this, we can express our DSL because we've already seen this ability of passing something implicitly, and that's exactly what we want. So we can define our method group as something that takes a name, because we need to name things.
Yeah.
And it takes a function that carries that group context parameter implicitly throughout its execution. So we can just say group context, something like this, and it returns a unit. And we're not going to provide the implementation for now. Right, so we have this. What else? We need something that will carry the testing context through. And in this case, we want to enforce the fact that we can only nest test cases inside of group context. So inside of the groups. So we're going to use a using parameter for that. So we're going to say using group context. And we don't need to name it, to be honest. And then once we verified in the time signature that we are inside of some sort of group context, we can allow the user to define the test. So we can say test context. And we're also going to use an implicit function over here, like that. And after all, assertions. So assert name string and some sort of condition. And it's going to be using tx, which is a test context. Right? And it's not going to do anything really. So we're just going to register the assertions inside of that test context because we have the reference to it, but at this point we're not providing implementation. So I'm just going to use unnamed implicits. So now that we have this, there's one thing that we haven't covered, and that's before all. And what we want to enforce in before all is that it can only be used inside of the group context. It cannot be as part of the test. It cannot be as part of the if assertions had blocks. It could not be as part of assertion. So how do we do that? Well, in Scala 3, there is a new thing, which I think actually used to be a part of Shapeless library, and it's used in implicit search resolution, but now Scala provides a similar functionality out of the box, and it's called not given. So,
wow, what a turn!
I like the name. Yeah. So a not given. And not given is a useful construct to be able to provide some sort of instances and use the implicit resolution mechanism to only succeed where such instance is not found. And in our particular scenario, we can express that using the group context and the test context, because when we define the method before all, we want to say that it should be defined inside of the group context, but it should never be defined inside of something that carries an implicit test context. So we want to avoid nesting it.
Yeah, and maybe before we proceed with before all definition, how about we just uncomment this, right? And then we command before all and after all, and just verify that everything works so far.
So we haven't provided the implementation, so it's not going to compile, but we can just define a method that uses all of this. So we can just say my test spec, just to avoid running it, basically.
Yeah.
So, I'm using parentheses.
I mean, you just need this, like visual stimulation.
Pretty much, yeah. And actually, I don't remember the syntax for doing this sort of stuff. We can come back to that later, because I'm interested in what it's going to look like if we try to remove the brackets in this.
Yeah, but let's say if we just save this file now. Yeah, so this compiles. And one thing that is worth mentioning is that, so here, inside this block, we have group context. But this group context is actually propagated all the way down. So here we also have this group context.
Exactly.
Right.
Yeah. Which means that it's going to be difficult for us to define something in a test that prevents it from being used in, because the group context is available for the whole duration of the block.
Yeah.
So we're not going to be able to reject it, basically. So we can't really say that the test cases should not be defined or something. Yeah, for example, if I wanted to do assertions and verify that they can only exist inside of the test context, at this point, well, actually, my first thought was that it was impossible, but actually it's possible because the test context is only available inside of test cases.
Yeah.
So you can't do like a top level thing over here. Well, I hope. Yeah. So it's missing an argument. Well, let me just do this. Yep. No implicit argument of type test context. So that works. And if we try to move things around a little bit, we can verify that everything compiles the same way. So no group context, no test context was found. Beautiful. So let's go back to the interesting bit, which is using not given. Because what we want to express is that you have this method before all, which takes some sort of a function, which does some sort of a setup. We can make it be whatever. In fact, it can actually, because it's a group setup, it can actually just take the group context implicitly as well. You can just say group context like this. So this is the setup, which will set up the group context and then tear it down using the after all method. And at this point, what do we want to say? So the first thing we want to say is that only when the group context is in scope. So we can say using group context. That's cool. And I'm going to new line here because we're going to need some space for this. And then what I also want to say is that this method should not be used in places where a test context is available. And to do that, I can just use not given. So I can say that not given test context, and then yeah, I'm going to provide some implementation. So this compiles, and basically what we're saying here is that the application of this method will only ever succeed if it's in scope where there is no such thing as test context, but there is such thing as group context. In all other cases, it's going to fail. So let's see if this actually works. So before all over here, working beautifully because there's no test context, nothing. What about inside of a test case? Aha, so in test case, we see, well, the error message could have been improved. It says no implicit argument of type not given. Yeah, it's a bit of a...
Yeah, double negations are hard. When it's also about implicit, that's, just, you know...
Yeah, pretty horrifying. So let's just improve that and improve this message a little bit. And to improve that message, we can just use the good old trusty implicit not found, which, if you're a library author, is probably the single nicest thing you can do for your users is to provide a good message when an implicit is not found. Because the Scala 2 compiler doesn't do a great job of explaining what happened during that implicit search. So we can use the implicit not found annotation. And something that I found out recently is that we can actually use a message which is a variable, but it's a stable identifier, so it's a constant. So we can say this before all method can only be used inside of a group, not test blocks. I mean, this English could have been improved, but it doesn't matter.
It's still much better than the default message, so let's roll with it.
Yeah, that's true. So we can use this implicit not found annotation, and we can put it on this one. Implicit not found, and we're just going to do a message. But I think we also need to, well, let's see what happens now. So far not great, some problems. And I think what we found out is that it needs you to use actual named using parameters. So you need to say that this is a GTX and this is a not test.
Okay.
So that didn't work out for some reason. That is strange.
So, does it have to be final? Yeah.
Oh,
wow.
Yeah, you're right.
Wow.
Nice.
It's interesting that the compiler actually accepted the non-final version, but just, you know, discarded the message without saying anything.
Yeah, that's not great, is it?
No.
But I think everything that has to do with annotations or macros or like reflection-based stuff, I think the Scala compiler is actively discouraging you to use it, whilst not providing any useful information whatsoever about it.
I mean, a couple of things can definitely be improved for, you know, the release candidate or something.
Yeah.
All right, but let's
So,
if you know what you're doing, then this is actually very nice.
Yeah, and you can do all sorts of things. So yeah, you can just rename that for shortness, and then you can nest it as much as you want, and you get this nice message which actually makes the user correct the error rather than give you a very cryptic thing. Actually, speaking of cryptic things, something that we actually haven't looked into is are the implicit messages better in the general sense when you do some sort of implicit resolution? We actually haven't done much kind of inductive resolution sort of stuff.
Yeah.
Do you want to see what it looks like right now, or do you have any more questions about this particular scenario?
You know, actually, I think when it comes to implicit resolution and this like inductive definition of implicit and all this stuff, this seems like a part of a bigger story about sort of generic derivation and metaprogramming. So maybe we could actually have a separate conversation about this stuff, and just finish with implicits as at this particular part.
Yeah, I mean, we could definitely leave the derivation out of this. First of all, because I won't be able to write it straight away. I would have to have a written example for it because it's still a bit low level. But on the other hand, we can do a very quick demonstration using our own divisible class, basically,
right.
And see.
So you actually want to break like 1.5 hours limit.
Yeah. I'll promise it will take 5-minute journey, 5-minute adventure in and out.
Right.
Perfect.
Yeah.
Not a single issue.
Makes sense.
Don't worry about it. Yeah. So, like, what I want to do is basically going back to our divisible situation. I want to provide. What did I want to do? It's divisible. Yeah. So I wanted to see what the error message is going to look like. I think that's the syntax. I keep forgetting the syntax. It's a bit embarrassing. And then we want to say divisible. Yeah, sure.
There's something
Did
missing.
I misspell?
Yeah.
I keep misspelling it. That's what I'm doing. There we go. Okay. I need to remove this bit so it doesn't actually. Oh, test conversions. Okay. Let's just comment this out completely. Cool. And what I wanted is to divide one list of A to list of A. And then what I'm going to do in this, I'm going to zip it with another list and then map. And then we have case A and B. And then we're going to use the divisible instance for A to divide those two together. Okay, so that seemed to have worked out.
Okay.
Right, so let's see how this works, right? Summon divisible for list of int. And I want to divide. Did I misspell it again?
No, looks fine.
1, 2, 5, 10, 15. List 5, 5, 5. Something like this.
All right.
Okay, so it's saying, it actually correctly identifying that I'm missing a given instance. So let's just import all of them. Can I do this, I wonder, without the brackets? It looks a bit weird, right?
Yeah.
It just doesn't feel right. And also the syntax highlighting. Well, actually, no, the syntax highlighting seems okay for this. Cool, so that instance...
Yeah, looks like it worked.
Yep. So let's see if I just do a slightly more complicated one. A list of string, which I haven't provided a divisible for. Okay, so what do we get in terms of the error message? No implicit argument. Ah, look at how beautiful that is. So it says that in the list divisible, what's missing is a divisible for a string.
Let's
so
scroll.
it showed me correctly.
Right, yeah.
Oh, it's gorgeous. And it actually gives you an error message, which basically shows that the list divisible has been applied, and it's been applied correctly, even for a nesting case. But what's missing is the sum and divisible.
Right.
Isn't that gorgeous?
I mean, actually, yeah, I mean, you're right. It was worth it. I like that.
It was worth it, right?
Yeah, yeah.
5 minutes.
I like that it actually shows you the sort of, the derivation chain. Yeah, so much better. Wow.
Yeah.
This is
Keeps
mind-blowing.
on going. This is awesome. So I think this is better, and I think with all the other things that are happening. So if you have been using Scala, you probably would have been acquainted with a library called Magnolia, which gives you a really nice universal macro that allows you to do very fast kind of derivation of type classes. And that gives you very nice error messages when it cannot find a particular leaf node in your massive case class or your hierarchy. And this is now part of the compiler, not Magnolia itself. Like the output is very different and probably not as refined as John Pretty would have written it. But
yeah.
I feel like this is really nice, and it will really help the beginners, because once you grasp the inductive nature of implicits, which is really what they're for when you're doing functional programming rather than dependency injection or whatnot. Once you grasp that, understanding this should become much easier, because the Scala 2 compiler will just shout at you and say it's your fault, and that's it.
All right. So no, I mean it's definitely a very nice improvement. All right. So I guess actually at this point we are ready to wrap this up. So just to a very brief summary, we have talked about implicits in Scala 2, all the different use cases of implicit in Scala 2. Then we sort of contrasted and compared these with the Scala 3 version, with the given and using, and also we talked about extension methods, how they are implemented, what are the quirks, like where to put them, how they look in the bytecode, all this stuff. Then we talked a little bit about imports and implicit conversions and the new default. I mean, it's not the new default behavior, but rather the default behavior in Scala 3 when it comes to conversion objects, that it just doesn't import them by default. We also talked about implicit functions and how you can use implicit functions to structure your DSL, and the last final bit about derivation of implicit values, which was, it was actually 5 minutes and it was well worth it. So yeah, I mean, that's really great. Thank you very much, Anton. That was just awesome. I learned a lot, and I really hope that we will actually talk about the generic derivation and macro programming maybe at some later time, but just sort of to wrap this whole thing about Scala 3.
Talk about it, because that will give me an opportunity to actually learn and understand it, which I don't at the moment. So that's going to be fun.
All right, so looks like we are in agreement. Big thanks to Anton for finding the time to actually talk about Scala 3 implicits, and thank you for watching. I hope this video was helpful, and see you next time. Peace.